In this video, we'll be talking about secants and tangents, and we're going to also talk about the angles that these secants and tangents make when they intersect. First inside the circle, then on the circle, and then finally outside the circle. So let's start off by talking about what a secant is. So a secant is a line that crosses the circle in exactly 2 points. So notice I said it's a line and not a line segment. So it crosses here at that point and it crosses here at this point as well. So it's a secant. Now you may be wondering, why is it a secant and not a chord? And just to remind you, a chord is a line segment that goes from one point of the line to another point on the line. So this portion of the secant is a chord, but the whole line is called a secant. Okay, so now let's talk about what a tangent is. So whereas a secant touches a circle in exactly 2 points, a tangent touches a circle in exactly 1 point. So let's say this is the point here. A tangent is a line, and I did a bad job here because it looks like it's touching multiple times, but a tangent is a line that touches the circle in exactly 1 point and 1 point only. So a tangent, therefore, cannot go inside the circle at all. It's going to 1 point, and then it's going in both directions outside of the circle. So just to make sure that we have a full understanding of secant and tangent, I'm going to draw another secant in my first circle. Touches exactly 2 points. Another tangent is going to be drawn on the second circle. Touches exactly 1 point. All right, so now that we know what a secant is and what a tangent is, let's move forward and look at the angles that they create. Okay, so here we have two secants and they're intersecting each other inside the circle. And this intersection is creating some angles and some arcs. So here's what we need to know about the angles that are formed by intersecting secants inside the circle. I'll write it down using angle 1 first, and then I'll explain. So the measure of angle 1 is going to be equal to half the sum of the intercepting arc, so the measure of arc AB, and that vertical arc, the arc that's across, so plus arc, measure of arc DC. So in words, this is really saying that the measure of an angle created by two intersecting secants or chords will be half the measure of its intercepting arc plus the opposite arc. Let's try to figure out what we would have if we try to do the measure of angle 2. All right, so intercepting arc of 2 is here, the opposite arc of 2 is over here, which means the measure of angle 2 is equal to half the measure of arc BC plus the measure of arc AD. All right, so let's look at a quick example. In this example, we're being asked to find x, and x is being created by two intersecting chords. So intersecting chords and intersecting secants behave in the same way. So we know that angle x is going to be half the measure of that arc plus the measure of that arc. And conveniently, we have both measures. So x is going to be equal to half of 84 plus 50, which gives us, when we work it out, 67 degrees. So angle x is 67 degrees. We weren't asked to find angle y, but it's pretty easy. Once we see that angle x is 67 and angle y is the vertical angle, is actually equal to 67 as well. All right, let's move on to when the lines intersect on the circle. Okay, so here we have a secant and it's intersecting with a tangent line. So if we have a case in which the secant intersects the tangent line on the circle as shown, then the angle that is created, so in this case, let's look at this angle here, let's call this angle 1. The angle that's created is going to be half of the intercepted arc. So angle 1 is going to be half of this arc here. Over on the other side, angle, let's call it 2, this is a big angle, is going to be half of this intercepted arc right here, going all the way around to where it meets the tangent. All right, so let's look at an example just to be sure that we understand this. I'm just going to draw it really quick here. So we have our tangent, and we have a secant. So now, if I tell you that this measure for this intercepted arc is 300 degrees, and then if I ask you for the measure of angle A, B, C, what would that be? Well, that would be half the measure of the intercepted arc. So angle ABC, hold on, measure of angle ABC would be equal to 150 in this case, 150 degrees, because it is half the measure of the intercepted arc. All right, so we've looked at what happens when two lines intersect inside the circle. We've looked at what happens when two lines intersect on the circle, so you can guess what's coming next. What happens when two lines intersect outside of the circle? Okay, so there are three ways that we can have these lines intersecting outside of the circle. We can either have two secants intersecting, we can have one secant and one tangent intersecting, or we can have two tangents intersecting. These are three cases in which they're all intersecting outside of the circle. But, however, they are the same, really. What happens is exactly the same. So, if we want to find the angle of intersection that's created by the intersection, so if we want to find the angle A in each case, the angle is half the difference between the intercepted arc. I will repeat, the angle is half the difference between the intercepted arcs. So, for example, we're looking at the first case. So we're looking at angle A. This is an intercepted arc, and this is the other intercepted arc. And so in that case, angle A, the measure of angle A, is equal to half arc DE minus arc BC, and it's actually half of that entire expression there. All right, the other one is similar. Measure, let's do that in blue. Measure of angle A is equal to half the measure of the intercepted arc, the big one, which is DC, and I forgot to put my measure sign in there, so you know that should be here, measure. All right, so minus measure of the small arc, BC. All right, and we would do the same thing for the third one. So let's do that in green. For the third one, we have the measure of angle A is equal to half the measure of the big intercepted arc, so BDC, what should I call that? Not big arc, but major arc. All right, minus the measure of the smaller intercepted arc, which is BC. All right, so that's how this works, and we can take a look at an example and then we're done. In this example, we're being asked to find the measure of arc CD. So now we already know the measure of angle A, and we know that the measure of angle A is half the difference between the measure of arc CD, the bigger of the two intercepted arcs, minus the measure of the smaller arc, which is BC. All right, we know most of this information already, so we can plug in what we know. 56 is equal to half of arc CD. We don't know what the measure of arc CD is. That's what we're being asked for. Minus the measure of arc BC, which we know is 95. All right, so we can go ahead and solve that. Multiply both sides by 2, and we get that 112 is equal to the measure of arc CD minus 95. Finally, we can go ahead and add 95 degrees to both sides, and we get that 207 degrees is the measure of arc CD. And we're done. That's it.